The difficulty with this question is it looks worse than it actually is. It's ever so wordy, but if you read it carefully and think things through, the maths and the statistics shouldn't actually be a problem. Now if we read it, we've got a probability that it won't chime is that. So the probability it will chime is 0.9. And this actually is a geometric distribution, meaning we keep going until we hit failure, basically. Failure being it doesn't chime. Now, the clock is started at 5 minutes past midnight. Find the probability the first time it does not chime is at 0600. So it has chimed at 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock, 5 o'clock. Or rather 1 o'clock and 2 o'clock and so on. So 0.9 times by itself 5 times. And it fails to chime at 6 o'clock. That gives us an answer, 0.0590, 3 sig figs. Part B. Find the probability that the first time that it does not chime is before 6 o'clock. So our options are 1 AM, 2 AM, and so on. Okay, so the probability that it does not chime at 1 AM is that. Not chime at 2 AM, it's chimed once and then it doesn't. 3 AM, it has chimed twice, but at 3 AM it doesn't. Cubed, 0.1, and this one is chimed 4 times and then it doesn't. And we work out all of those, it's 1 AM or 2 AM or 3 AM and so on. So we add all of those answers, 0.40951, or to 3 significant figures, 0.410. Part 2. This clock chimes twice per hour. So what we've got is it chimes, I'm going to work in decimals, it's just slightly easier, 0.95, doesn't chime, so they're the values I'm going to be working with. Part A. It does not chime at 0030 is 0.05, or it doesn't chime at 0130. Now if it doesn't chime at 0130, then for the first time, then it has chimed at 0030, and so times it has chimed at 1 o'clock and it has not chimed at 0130. Typing that in, 0.0951. Part B. So let's just start this off. It doesn't chime at midnight. Is 0.05. It doesn't chime, first time it doesn't chime is at 1:30. So it did chime at 12:30 and 1 o'clock, but not then. The first time it doesn't chime is 2:30, means it doesn't chime at, or rather it does chime at 12:31, 1:30 and 2, that's 4 times. Times 2:30 it doesn't. So what we've got here is the start of a geometric progression, a geometric series, with our first term 0.05. Each time we're multiplying by a common ratio of 0.95 squared, because we're only interested in it not chiming at 30 minutes past the hour. Sum to infinity. So sum to infinity, it's on the formula sheet, I believe it is, U1 over 1 minus R. So we type that in, 0.05 over 1 minus 0.95 squared, typing it in carefully, and we get 20 over 39, or as a decimal to 3 sig figs, 0.513.